So, can we work out the nth term of this sequence? Can we find an expression that describes this sequence? So what I'm going to do is my usual techniques. Let's look at the difference between each term. And here I can see that the first difference, well, they're not the same. They don't have a constant difference. So it can't be linear, can't be arithmetic. Well, how about the second difference? This one also isn't the same, so it can't be a quadratic. But then I notice that the third difference is the same. And I think, wait a minute, maybe this could be cubic. And so, why don't we try and look at a general cubic sequence and see if we can match that general cubic sequence up to this sequence here to find our nth term, our general expression. So, we know that all cubic sequences have to be in this form, where we have some amount a of n cubed plus some amount of n squared plus some amount of n plus some constant at the end, where n is the term in my sequence. You can imagine this looks very similar to a cubic equation or an expression for any cubic. They always will have this expression. And what we're going to do is we're going to do this generally. We're going to look at a completely general cubic sequence and then use the formulas that we get to actually apply this to a specific cubic sequence. So what we're going to do is we're going to start with n equals 1, 2, 3, 4, and 5. So here we're just looking at the first 5 terms in this sequence, where n represents where in the sequence that term is. So when n equals 1, that's our first term. So what we'd do is we'd sub that n into our general expression. So when n is 1, we have a times 1 cubed plus b times 1 squared plus c times 1 plus d. Our n has been replaced by 1. And we can do the same thing here for 2, 3, 4, and 5. We're just substituting the value for n into our general expression for the cubic. And what that means is that when I simplify these, the first term of every single cubic will look like this: a plus b plus c plus d. Because it's 1 cubed, which is 1 lot of a, 1 squared, which is 1 lot of b, 1 c, and a d. Similarly, these will always be the second, third, fourth, and fifth terms of my cubic sequence. Now we don't know what a, b, c, and d are, but when we get our actual sequence, we will. And what we're going to do now is we're going to find the difference between each term. How did I get from the first term to the second term? And to do that, we could just find the difference between them. So to get from a to 8a, it's 7a, b to 4b, it's 3b, c to 2c, it's c, and the d's, well, to get from d to d, there's nothing. So the difference between these two terms looks like this. It's another expression. Similarly, we can do the same thing for the next few terms, finding the difference each time. And algebraically, we get these 3 expressions here. And you can see that those expressions, when you add it to the expression before, gives you the next one. So 8a plus 4b plus 2c plus d plus 19a plus 5b plus c gives you 27a plus 9b plus 3c plus d, and so on. Now we're going to find the next difference between them. In this case, it's 12a plus 2b for the first two, and then 18a plus 2b, 24a plus 2b. Now this might feel like a lot of algebra and that it might keep going forever, but actually what happens is the third difference in a cubic sequence is always the same. And the third difference is always 6a. And we can see we've got 2 examples of that here, where the difference between 12a and 2 plus 2b and 18a plus 2b is 6a, and the difference between 18a plus 2b and 24a plus 2b is also 6a. But if I kept going with all the terms, that third difference would always be 6a. And actually, we only need to look at these 4 bits here. That is what's going to be important to us, because we're going to match these 4 expressions up to our cubic sequence. So here we go. We have this sequence here: 11, 42, 113, and 242. And we get told it's cubic. And we have our little working out down at the bottom, but once again, we only need these 4 things. And let's see why. So I'm going to start filling in the differences. To get from 11 to 42 is 31. To get from 42 to 113, it's 71. Yep. To get from 113 to 242, it's going to be, I just do 242 minus 113, it's 129. Does that look legit? 129. Next, and obviously you can use a calculator for this bit if you'd like. This is 40. This is 58, and the difference here is 18. And if I had more terms in the sequence, what you'd notice is this difference would also be 18. So actually, I can fill in the next terms like this, because if I know this is 18, the thing that goes here would have had to be 76, and so the difference here would have had to be 205. So actually, we would know what our fifth term is. It would just be 242 add 205, because the third difference in a cubic sequence is always the same. And now we just match them up with our general sequence. So we have that 6a down here is exactly the same as this. So 6a has to equal 18. 12a plus 2b has to equal 240. How about 7a plus 3b plus c? Well, this guy has to be the same as 31. And finally, a plus b plus c plus d, this guy here, has to equal just my first term, which is 11. So now I have 4 equations from my cubic sequence, and I can actually use simultaneous equations to solve this. So we have these 4 equations. 6a is 18, 12a plus 2b is 40, see there, 7a plus 3b plus c is 31, and a plus b plus c plus d is 11. So let's solve these. Here we can just divide by 6, we get that a equals to 3. Great, we can then substitute that into there, we get 12 lots of 3 plus 2b equals to 40. So that means that 36 plus 2b equals to 40, 2b equals to 4, b equals to 2. Great, now we can use both those things in the next one, and that's why we build from the bottom up, from the 6a equals 18 up to the top, because each time we remove some unknowns. So here we have 7 lots of 3 plus 3 lots of 2 plus c equals to 31. 21 plus 6 plus c equals 31. c equals 31 minus 27 equals to 4. Very nice. Next we have 3 plus 2 plus 4 plus d equals 11. That gives me 9 plus d equals 11. So d has to equal to 2. And now we have all the missing pieces from our original general cubic sequence, because we know that all cubic sequences are an cubed plus bn squared plus cn plus d. The rule for this sequence we have down here is going to be 3n cubed plus 2n squared plus 4n plus 2. And that is my nth term. That is my general formula for this cubic. And you can use these same 4 equations. You can either memorize them, the 6a, the 12a plus 2b, the 7a plus 3b plus c, and the a plus b plus c plus d to do this for any cubic, or you can build it yourself. Now, can you use the exact same method for quadratic sequences? And how about linear ones? Now, of course you can, and actually, this is taught in the GCSE curriculum in the UK. As the hint, so that you can try it yourself, quadratics have to look like this, and linear have to look like this. Thank you very much for watching. See you in the next video.